What's wrong with that?
Nothing wrong with that. Nothing wrong.
Whatever floats your boat.
That's right. What do we call it? Infinite limits. Sweet. Infinite limits.
So we can just put infinity as the answer.
You can just put infinity on the end and call it good. That's right. And then you're done. The problem is conceptually that's a weird thing. So
Yeah, it's like almost contradictory.
it's almost contradictory.
Like,
exactly.
It never ends and it limits.
How is that? Yeah, this is a paradox.
This is a paradox. I don't even know what a paradox is, but this feels like a paradox.
It is.
I don't know what a
All right. Yes, this is going to be the last section here. It's kind of a weird concept. It is an infinite limit, which seems kind of odd because it is. What we'd like to do is just kind of talk about real quick again what the heck a limit even is. Okay, it's always good to go back to kind of the roots of limits and what we're actually trying to find here. So what do you guys think a limit is? Like, what does that mean to you? Confusing, yeah, that's one thing. Yeah.
Something that you can't do.
Something you can't do. But we actually can find limits, right? We can find these limits. We're finding limits of values that might not exist, or of actual values that might not exist. But we can find the limit of a function.
Yeah.
It's what?
Progress.
It does what?
It halts.
Halts. But the idea of a limit is that we're getting closer and closer and closer to one specific number. A number we might not be able to actually reach, but a number that is very specific that we obviously see what the answer is going to be. Now, the value might not actually work, which we've seen on all the stuff that we've done. So we have some limits that don't actually go to specific values, and before we just said those limits don't exist because they don't make sense as far as our main definition for what a limit is. We're going closer and closer to one specific point. So on this one, we're going to kind of follow along those same lines. The answer is going to feel weird here, and we have to try to interpret what the heck the answer is even saying. So first off, let's go ahead and find the limit as x approaches. Let's go 2 on this one from the positive side of our f of x. And then we'll say our f of x function equals, how about 4 over x minus 2. Okay, so there's our function. Probably your gut shot reaction when you see this function is to, well, either 1, graph it, or 2, put it on your calculator. One of those two. Okay, those are good things to be thinking about. Okay, so go ahead and graph that real quick. See what it looks like. You might have a rough idea what the graph looks like anyway. It's just based on some asymptote work. Now, I don't want to hammer too much on asymptotes. There's a little bit of asymptote work on your homework tonight, but can you guys all find the vertical asymptote for this guy? It'd be 2, right? Funny, the limit's going toward there. But we're going to find the vertical asymptote for this one is going to be at x equals 2. Okay, so whatever makes the denominator 0, that's a vertical asymptote. Now, there's exceptions to that, and I'll explain that on a couple different problems in a bit. But that helps us a little bit as far as the rough idea of what the graph's going to look like. If I have an asymptote of 2, that means I can go out to x equals 2 and draw a vertical asymptote. Okay, so I know my graph isn't going to go through that line, which is going to be kind of funny because I'm taking my limit as x goes to 2. I can't direct substitution plug 2 in because it's undefined, right? It's not my domain. Okay, so go ahead and graph that. Was it kind of a swooper up here, right? Yeah. It looks something like this, and then something like this. Okay, so that's what that basic graph looks like, and it's going to be pretty close. Now, if we're taking the limit of this as x approaches 2 from the positive side, what we have to do is just, maybe on this one, just look at a table. This is overkill, I know. But let's look at a table real quick. We want to find the value of 2. That's what we're looking for. And we want to find it from the values on the right side of that graph. Okay, now the right side is pretty particular. That means that on the graph part, I'm coming in from the right side, coming in this direction right here. Okay, so if I'm plugging values just on the right side, that means I want to do like 2.001. I want to do 2.01 and then 2.1. Those are some decent values that I probably want to plug in and check. Okay, so as I plug those in, and obviously you can go second calculate value. That's a pretty quick way to plug in those values pretty simply. Okay, but let's go ahead and I'm going to go ahead and throw that in there, unless you guys already have it. I'm sure you guys do. 4 divided by parentheses x minus 2. And so there's my second calculated value. There's my graph. Looks something like that. Pretty close to what I have. Obviously, they're not going to draw the vertical asymptote in there, but hopefully it is at 2. Looks like that's about correct. Might help to put in 2 real quick. It doesn't hurt to try direct substitution at the beginning. So we get x is 2. That didn't work. Backfired. Nothing for y. So now I'm going to come from the right side. So I'm just going to plug in those values. Like 2.1, I get 40. 2.01, I get 400. I wonder what the next one is.
4,000.
Oops, too many zeros. Hey, okay.
Put that in my head.
Okay, now this is the unfortunate part about infinite limits. Okay, what's this number going towards? Is that a number? No, that's a concept, right? Infinity is not a specific number. I can't say, yes, infinity is right here, right? It's not going to a specific number, which means we should say that this limit doesn't exist. Okay, you guys okay with that? Okay, this limit doesn't exist. However, we do know at a point, or we know where this limit is going towards. The limit doesn't actually exist, but we're going to say that this limit equals positive infinity. Okay, now the weird part about this is we're not actually saying the limit exists. The limit still does not exist. That's the big jump for today, okay? The limit doesn't exist because we're not going to one specific number. We're what they call increasing without bound. We're going up bigger and bigger every time no matter what. So since we're not going to one specific number, then this limit doesn't exist, okay? So that theory still holds true. The problem is we're saying it equals infinity, okay? What that's telling us, this is really a does not exist. That's a does not exist limit. Okay, this limit does not exist. However, this is just giving us a more specific answer for why it doesn't exist and what it's actually doing. Okay, is that sticking a little bit? Does that make sense? Kind of a weird. So that's why the infinite limit seems kind of odd. So we are still doing a does not exist limit. Okay, but if you just put does not exist on like a test or whatever, that's correct, but it's not going to be the complete answer. Okay, we want to know why it doesn't exist. In particular, where is it going? Okay, it's going to negative infinity. Now for, let's just go ahead and do this from the other side. Let's say I did the limit of this guy as x goes to 2 from the left side, from the negative side. And the nice part is we can look at our graph of f of x. Sorry. We can look at our graph, and our graph actually tells us, where we're headed, which is kind of nice. On this one, if I was coming at 2 from the right side, that means following here. And notice this graph just goes straight up forever. Okay, so that means it's going up really, really big number, infinity, without bounds. So that's why that guy equals infinity. Okay, still does not exist. Okay, but we know specifically that it doesn't exist because it goes to infinity. Likewise, if I come from the left side now, okay, I'm still coming at a positive 2 from the left side. That's what that stands for. So from the left side right here, what's this one headed towards? Negative infinity. Okay, so this one is negative infinity. So the limit of this function of f of x is negative infinity. Still doesn't exist, but we know why it doesn't exist. It doesn't exist because we're headed towards negative infinity. Yeah.
Can you just eyeball it and not do this?
So you can just eyeball it. You don't have to do the table on these. If you're going towards asymptotes, you can totally just go off the graphs. And a lot of times they give you the graphs, and you can just look. Say, all right, well, it's going up, it's going down, life is good.
So you don't have to do the table.
You don't have to do the table. Right, it was just to show kind of where that's going. Okay, just to show that that's not going to one specific number. What's up?
Do y's have limits?
Do
Like the y values, because like on that graph right there, y can never equal 0.
True, but you'd have to change your function, which is kind of weird because everything as far as your limits are concerned, it's always x going to a number of f of x. Now, if you change this to a function in terms of y, which this one we could do, let's say you found the inverse in this guy, let's say we solve for y, that would be a function in terms of y, and then you can do y as it approaches certain things, and that's going to be more that's more third semester calculus stuff. So you're on the right track, but we're waiting a while to get to that. So that has to do with sequences and series and everybody's favorite thing. Yeah, whether it converges to one specific number or not. So, anyways, all right, cool. So that goes to negative infinity. Now let's go ahead and join those together. Okay, let's go ahead and join those together. We still know that the limit isn't going to exist on this one. It still does not exist. But let's say I go as x approaches 2 of my f of x. Now this one's kind of weird because if I come from the right side, I'm going to positive infinity. If I'm coming from the left side, I'm going to negative infinity. And those aren't going to the same values, even though they're not, or the same concepts, I should say. They're not going to positive infinity and positive infinity. So this one right here actually does not exist, and there's no fancy answer I can put for that. Which is weird. All three of those don't exist, but this one doesn't have a specific answer on why it doesn't exist. Okay, this one goes in opposite directions. Now the nice part is if you have a limit that doesn't exist for one of these, chances are that told you that they go opposite directions on that particular one. Okay, so is that kind of making sense? Not too bad. All right, now let's say I went fairly general on a graph. Let's say I had some graph that looked like this, and this is just going to be my g of x function. Okay, and we don't know exactly what the graph looks like, or I'm sorry, what the function of it looks like. But let's say my graph goes something like this, goes down, and then something like this, and then goes down. Okay, so if I go the limit of this guy as x goes to 0 of my g of x, and let's say I go from one side. So I'm going to come from the positive side on this one. Okay, and we're going to do the same thing. I'm going to go the limit as x goes to 0 from the negative side, from the left side of g of x. And then the limit as x goes to 0 from both sides. And once again, we don't really need a specific equation for this if the graph is given to us. We just want to try to interpret the graph on what they give us. Okay? So on this one, you guys probably already have the answers already written down, but the limit is x goes to 0. We're approaching this 0 value right here from the positive side. So from the positive side comes in here like this. We're going down without bound. We're going down forever there, so it's going to go to a negative infinity. It still doesn't exist. It still does not exist limit, which is kind of an odd thing to think about, but we can't go to a specific number. Okay, so it doesn't hurt to put that in parentheses, but negative infinity is going to be your answer for that. Okay, the limit for this one still doesn't exist, but as I come from the left side, from the negative side right here, goes down to negative infinity. Still doesn't exist. And then the last one, limit as I go from both, since both of those match right there, then negative infinity is going to be your limit for that one. Okay?
But it still doesn't exist.
Say it again.
But it still doesn't exist.
But it still doesn't exist. All of these are does not exist. It's telling us why it doesn't exist. In specific, it's just being a specific answer for why it's not working. That's all it's saying. Okay? All right, cool. Feel fairly good about that? Not too bad? Okay, a couple of little tricks to watch out for. Let me just throw a couple little curveballs at you, and then I think we'll call it good. Okay? Couple little tricks. Let's go ahead and do a trig function because those end up messing with people's brains. Okay, let's go ahead and find out one or two little, what they call C values. You had a couple problems that were kind of like this. Find the C values for which this limit doesn't exist, and then why. I like how the gut reaction is to graph this. That's good. Make sure you're in radian mode. What was that? That was a weird sound cell phone. Was it mine? I don't know.
Freaking out.
Oh, when you put one
They're gonna kill us all.
Is that right?
there we go.
You guys looking like that? Hopefully. Good. Okay, so now what I'm looking for is I'm looking for all these possible values for where my limit might not exist. Anywhere on this graph, anywhere actually on the graph, I'm going to have a limit here. Okay, so all my possible C values work here. So if I take the limit of this guy, the limit of h of x, as x approaches some C values, right? I want to figure out where that guy actually equals either infinity, negative infinity, or more specific, does not exist. Okay, so I'm looking for where this doesn't exist, looking for possible C values here. Okay, now any C value I pick, like let's say I pick the C value, well 0 is kind of an obvious one where it doesn't exist, right? At least on the graph, hopefully. So C equals 0, that's one possibility for where this one doesn't exist. Okay, now what's that?
What is C exactly?
C is my value right here that my limit is going to be heading towards.
Oh, I was C like all of these problems.
C just stands for a constant number, just some number that we can make up. Okay? So C is whatever number I'm actually solving for. I'm just finding out where this limit doesn't exist, where it might go to infinity, negative infinity, something like that. So I want to find maybe one or two of these. Now the book might give a generic answer, but I want to find a couple. Right here is 0. That's one option where it actually happens. To find out a couple of the other ones, you want to find out where all these other asymptotes are, okay? And you can do a little bit of guess and check if you want, or you can do a little solving. We got cotangent of x. We want to figure out where that equals 0 right there, or where that equals undefined right there, okay? So that means that cotangent of x, I want to find out where this is undefined. Now cotangent is cosine over sine, cosine of x over sine of x. And so I'm actually trying to figure out what makes the sine 0. I'm trying to figure out what makes the denominator 0. That gives me all of those asymptotes right there, okay? So a couple of those that give me asymptotes. Now, sine of 0 is 0, so that's why 0 is my first C value, but I just kind of looked on my graph on that one, okay? So now I want to figure out other points, other values where I might run into an asymptote right here, okay, for just this first one. Okay, so where's my first asymptote happen right here? At pi. Okay, this actual first one is at pi. And if you don't get that, you can always go second calculate and then value, and then type in some of your radian measures, but pi is one of them. Also, the thing that helps me a little bit with sine and cosine is I like to go back to just the basic what a sine graph looks like. I know it's been a while, but the sine graph looks like this, right? And here it's at 0, here it's at 2 pi, and then here it's at pi. So that's all the places where sine equals 0. So that's a good little extra helper if you get stuck. It's like, oh, I can't remember what's what. These little graphs can help you a little bit. Okay, you guys remember graphing those a little bit?
Yeah.
Tiny bit. Okay, so 0, pi, 2 pi. So that means that this is probably going to be a 2 pi right there. That's probably that value. Okay, so I've got a lot of c values now. 0, I got it at pi, I got it at 2 pi.
How do we know to guess pi and 2 pi?
Well, I didn't know to guess. I honestly went off this graph, and I knew the values were sine of certain things equaled 0. Is basically what I was looking for. Now the problem is you put that on your calculator. If you go second sine, I'm just assuming. If you go second sine, oops, let me close that out here. Sorry. Second sine of 0, right, which is a good logical step. I get 0. So it's only going to give me my first answer right there. So I have to find like those other coterminal ones that also give me 0. So going off a graph helps a little bit, I think. All right, so anyway, 0, pi, 2 pi. Those are all possible c values for where this isn't going to exist. Okay. Also, you can always go to like a trace feature, right? You can go trace and then trace along there and kind of see what value it's getting close to. For example, let me just type mine in so you can see what I'm talking about. So what did you guys do? 1 over tangent?
Yeah.
Okay, good. And then, oh, I'm in the wrong mode.
It's a circle.
Sorry. My other class were doing a bunch of trick stuff. They hate radian. There we go. That looks better.
I have a question.
Yeah.
How do you get your calculator to not graph that?
It's just like a bunch of lines.
It's tough. The best way to try to get them to go away, doesn't guarantee it, is to use the dot mode. So if you hit mode on your calculator, you can go down here to dot. And instead of trying to connect all the lines, sometimes it'll just put dots between them. So it'll just do dots. Now, it's kind of hard to see what the graph is, but at least you get a general sense of where they're going to go. It might take out your asymptotes. Now, the older your calculator is, the more likely it's going to put asymptotes in there, unfortunately. Because there's less RAM that's in there for it to process all of these things. So it just like connects the dots, more or less, so, which is bad. So anyways, now as we go to trace, I might change the mode because that looks a little weird. Now let's just go trace. And as I'm tracing along this value right here, notice I came from 0. 0 equals nothing. What's that? It's this button right next to graph. Okay, so hit trace, and then we can just trace right along that graph. And then, so it looks like 0 is where one of them is. Okay, and I just keep tracing. And it looks like I'm at 2.9, 3.19. Ooh, and then I jump to the other side of there, right? So between 3 and 3. That's pretty close to pi, right? So then we might just check second calculated value pi. Throw a pi in there, and sure enough, we get nothing for a value. So that's another option for a way to go about that, for a way to find it.
So
I should have put that under the screen. My bad. I'm an
that's
idiot.
fine. I'm here.
Should I?
What?
There. That everybody saw it.
But my question is it like, is there any way for our calculator to put it in terms of pi, or are we gonna have to do that ourselves?
Oh, well, it'll actually be, like I wrote pi right there. Right, you see how I didn't write out the first 100 decimals of pi. I can literally just put in pi like that. Now it's going to change it to a decimal, but it's going to go out to the first 100 places or whatever, so it's going to be really accurate. So let's say we're checking pi over 2, because we didn't run out sure what it is, right? So if I just go pi divided by 2, for example, it's going to figure out exactly what decimal that is, 1.57, to the first 100 decimals. So your calculator will do that for you automatically. So pi over 2, why doesn't pi over 2? Oh, because that makes tangent 0. So it's technically not, there's actually a hole right there on this particular one, but there's not a hole on the cotangent. Because cotangent is technically cosine over sine, and we only get in trouble where sine is 0. Now on the calculator, we don't have a cotangent button, so I had to use 1 over tangent, effectively making where tangent equals 0, also invalid. So that's bad. So
They should make a good one.
they should make a cotangent. I don't know why they don't, to be honest with you. All the things this thing does, and they don't have a cotangent button.
It's like they
Crazy.
can't.
All right, one last one, and then we'll be done. Okay, one last one. And then we'll call it.
Did didn't want to waste their time.
Okay, last one real quick here. Now, generally speaking, if you have an asymptote, it's usually a good thing, because where you have an asymptote, you probably have an infinite limit. So it's going to go to either infinity or negative infinity. As it runs into an asymptote wall, it kind of scoots up or scoots down. So having those asymptotes is a good thing to find. And usually asymptotes are pretty easy to find. However, some are a little tricky. You have to watch out for. And you've seen a little bit of this before. But a gut shot reaction on this one would be to say plus or minus 2 right there. Okay, that's what most people would probably say, that I have 2 vertical asymptotes. I have one at 2 and I have one at negative 2. Go ahead and graph that. It's always a good thing to think about. Just go ahead and throw the graph on your calculator real quick. Doesn't hurt to do that.
Do you want to solve?
Solving is always no. We're actually simplify would be a better way to. But I'm going to just throw it in there as is and just see what it looks like. Okay. Okay, so I should have an asymptote at 2 and negative 2. And of course, they'll try to trick you. Obviously, I don't have an asymptote at negative 2, looks like it. For some reason, went right through that asymptote. It's like, well, I should have a line right there. That I have one of them. 2 looks like it doesn't work. So I can calculate the value 2. Awesome. Y equals nothing. Okay, what about negative 2? Well, let's do negative 2. Whoa. There must be a hole in there, exactly. So we got to figure out how the heck there's a hole, right? So when holes happen is when if I factor this, let's say I factored this guy. The bottom one is a pretty easy factor. It's x plus 2, x minus 2. And so that's where I got the plus or minus 2 from. That's where I thought, oh, sure, I'm going to have both asymptotes right there. Okay. Well, if I factor the numerator is going to factor down to x, looks like a minus 4x plus 2. If I were to factor that guy. And then the x plus 2's cancel. Now, if I cancel that out, I'm effectively canceling an asymptote. Okay, I'm taking one of the asymptotes and just throwing it out the window. That asymptote is no longer there. However, I still can't plug in a negative 2. Even though this is a simpler version of this exact same equation, I can't plug it into my original equation because I get that, what they call that indeterminate value, 0 over 0, when it's the same thing over, indeterminate value is what it's called. Anyways, as I look at this right here, when those cancel, that's when holes get created. So we actually have a hole right there at that point. So it's kind of hard to see, obviously, on our calculator, but at negative 2 right here, I'm going to have a big hole right there, okay? And once again, the resolution doesn't work. Zoom way in, you'll see that it's not there, okay? So actually the only spot where this guy doesn't have a limit is going to be at positive 2, okay? So positive 2 is the only spot I have a limit, okay? Now, as I look at my graph right here, as I look at that graph right there, do I have a limit right here? Could we find that limit? Can we find that limit at this point right here? As x approaches negative 2, right? We could all do that, right? How would you do that? Probably come at it from both sides, right? See what the value is and call it good, right? So we're actually going to have a limit at this value, okay? We're going to have an actual limit. Might not be good, might not be pretty, but it'll be there, okay? We won't have one at the other one. We'll have it go to infinity or negative infinity, but still does not exist, okay? Are we all good with that? This is all making sense? Have I overfilled it enough? No reaction, that means yes. All right, so page 88, and the limit chapter is behind us, just about. And we get into the fun stuff.